Hey there guys, we are on to section 7.4 on angles of depression and elevation. We will be using trigonometry with this, and so that's why you learned all about SOH, COS, and TOA. So the questions of the day. What is an angle of elevation? What is an angle of depression? How can these be used to solve a right triangle? In this picture, you'll see that an angle of elevation and depression, so first of all, we've got a line of sight, which is the line from our eyes, so here's the observer, our eyes to the object that we're talking about, we are viewing. This right here from the ground up is called the angle of elevation, the angle of elevation. Now right here we have a hot air balloon. We have an object, this time not an observer, but just an object down here. Here's the sight line, and the angle of depression from the hot air balloon to the object is right here. Angles of elevation and depression always come from a horizontal line, always. Okay, so if we look right here, here's the birdie, the bird looking down to the doggy. This is the angle of depression. Notice a horizontal line was drawn. And then here's the doggy looking up at the bird. This is the angle of elevation. It comes from this horizontal line. In this scenario, we've got this right triangle. The person that's shooting, here is their horizontal line from where they're shooting from, or their eyeballs, I guess. This is the line of sight. This angle right here is the angle of elevation to the top of the basketball goal. And then if you look here, a horizontal line has been drawn in from the top. And this angle right here is the angle of depression to the shooter. All right, here's somebody looking. Here's the horizontal line. Looking down to the dog, that's the angle of depression. Looking up to the airplane, that's the angle of elevation. Here's the sun. We've got an observer right here. Here's a horizontal line. Okay, you look up to the sun. And what if it's wanting the angle of depression to the observer? If we put these all together, they are equal. They are equal. This slide just has some extra help if you need it. All right, so I want us to pause now, and I want to define these. And there's a bunch of different versions of a definition. I liked these. So an angle of elevation is the angle formed by a horizontal line and an observer's line of sight to an object above the horizontal line. Angle of depression is the angle formed by a horizontal line and an observer's line of sight to an object below the horizontal line. So pause me and finish up note card 242. All right, so here's note card 243. We are identifying angles of elevation and depression from this image. It's not letting me pause. Hold on. Find the... That's funny. Okay, well, it's all right. Oh, I took that image and I drew it so that I could explain to you as I go. All right, so there was a person here, and so that's your observer, okay? That's your observer. And what you need to understand is from the observer, here's your horizontal line. That's just your reference line. Go up this way to whatever was up here, and we'll look back at the picture in a minute. But this is an angle of elevation because you're looking up. And then down here to whatever was down here, that's an angle of depression because you're looking down. Now from whatever was right here as the observer, this is looking up from a horizontal line, so that's elevation. Okay, and then whatever observer is here from the horizontal line, always from the horizontal, is looking down, so that's depression. So now we're going to go and label that. All right, so I dropped the image that I just did with the document camera in here, and I'm starting to type here. So angle 1 was an angle of depression, angle 2 was an angle of elevation, angle 3 right here is an angle of depression. And angle 4 is an angle of elevation. So you need to be able to identify that and understand that they come from a horizontal line. That's note card 243. So go ahead and finish that up. Pause me and finish that up. Here's note card 244, a very special note that angles of depression and elevation are measured from a horizontal line. I've said that several times. Also because they are alternate interior angles, y'all, these are horizontal lines. So they're parallel. So these are alternate interior angles and they are congruent. Oh, didn't mean to do that one. Let's see. We'll do this. So this angle right here is the same as this angle right here. Oh, I don't like how I drew that, so let me try that again. This angle right here. That's a little better. Not real happy with it. Hold on. I know. This angle and that angle are actually congruent. So pause me and finish that up. All right, I wanted to give you some steps when you're solving these word problems because there's going to be a lot of words, a lot of stuff happening, and here are your steps. Read the problem at least 2 times and make sure that your calculator is in degree mode.
Graduation committee, let's just meet in Mrs. Bumgarner's room today.
Oh, okay, I don't know if you can hear that or not.
Once again, graduation committee.
Draw and label the triangle with the situation details, whatever it gives you,
At 9 o'clock.
the situation details. Draw a horizontal line from the location of the observer, whatever it is, and then make sure you've got that. Make sure you've got all the information, and then decide which trig ratio to use, SO, CA, or TOA, and then set up the trig ratio and solve. Pause me and finish up note card 245. All right, now we're going to get into actual examples and working these out. So here's the first example for the lesson. Note card 246 is an angle of depression example. And I do think it's advantageous for you to write the problem down on your note card so that when you're studying, you can see what it says. So Maria is at the top of a cliff and sees a seal in the water. If the cliff is 40 feet above the water and the angle of depression is 52 degrees, what is the horizontal distance from the seal to the cliff to the nearest foot? Now remember, we had to read it twice. I want you to read it twice. Then we're going to draw and label. So go ahead and pause me, write this problem down, and attempt to draw this on a scrap sheet of paper to make sure that you can do it and we can work through this. All right, so hopefully you've gotten this written down and you've attempted to draw it. All right, so here is my rendition. This is the cliff. Here's Maria. Here's the seal. She sees a seal at an angle of depression. So I've got to draw a horizontal line. Typically, you'll see them drawn with dotted lines because they're lines you have to draw and they aren't really part of the situation. And then it's an angle of depression to the seal. So there's the seal. Now, I can't remember what the angle of depression was, so let me look. It was 52 degrees. And it wants the horizontal distance from the seal to the cliff. Okay. So this angle of depression is 52 degrees. And it wants this horizontal distance, because this is the cliff right here. This is the cliff. Horizontal distance from the seal to the cliff. So I'm just going to put an X there. Now we know that this is a right angle. That is a right angle. And what can I infer? These two lines that I'm highlighting in orange are what? They are parallel. So this angle and this angle are alternate interior angles and they are congruent. So this is going to be 52 degrees. So the angle of depression from Maria to the seal is the same as the angle of elevation from the seal to Maria. All right, so now look what we have. We have a right triangle. I'm just pulling this off so you can see it different. That's got this of 40, this of 52 degrees, and this of X. We know how to do this. This was, let's see, Monday's lesson. We know how to do this. So which trig ratio will I use? Well, look at 52 degrees. This is adjacent, and this is opposite. So that's TOA. So I say tan 52 degrees equals opposite over adjacent. Cross multiply, that's like over 1. So X tan of 52 equals 40. To get x by itself, I need to divide both sides by tan of 52 because that's just a number. So it's 40 over tan of 52 degrees. I get my calculator. I've got to double check that it's in degree mode. I always want to check that. This one is. I hit mode and look at that. Now I type 40 over tangent of 52 and I have 31.25. So that distance from the seal to the cliff is 31.25 feet. And if I remember correctly, it's said to round to the nearest foot. Yeah. So to the nearest foot, we would say, where did it go? Okay. That it's 31 feet. So this right here is 31 feet. All right, so I dropped that stuff back in here so you can see what we did and the work that we did. Now here is the website I pulled this off of. Here's their picture and their work. And let's see, let me move this window down so you can see. And they say 31.3, which was what we got, 31.25, but it said around to the nearest foot, so it should be 31 feet. All right, next. Here's another one. Note card 247. Louisa is in a hot air balloon 30 feet above the ground. She sees the landing spot at an angle of depression of 34 degrees. What is the horizontal distance between the hot air balloon and the landing spot to the nearest foot? So I want you to pause me, write this down, draw an image, and then unpause me so you can see if you're right. All right. So here's my picture. We have Louisa in the hot air balloon. Her angle of depression to the landing spot is 34 degrees. The hot air balloon is 30 feet above the ground. Here's the right angle. Here's the ground. And it wants the horizontal distance from the hot air balloon, to the landing spot. So really it wants this distance right here, which is the same as this distance. Now, what do we know about this angle and this angle? Well, these two lines are parallel, so those are alternate interior angles. So I transfer the 34 degrees here, and I have a triangle with adjacent, opposite, so that's tangent again. So we say tangent of 34 degrees equals opposite over adjacent. Cross multiply. Remember, tan of 34 degrees is its own unit. It stays together. It never separates. Equals 30. Divide both sides by tan 34. I already have my calculator in degree mode. 30 divided by tan 34 is 44.5. 44.5. So what is that horizontal distance? It's 44.5 feet.